Something weird is happening on Jupiter. The more we learn about the largest planet in our solar system, the stranger it becomes. But at the same time, Jupiter can be more familiar than you'd think. No teacher in school ever told me that Jupiter had water and rain and a giant ocean. The story of this planet could leave you questioning everything. The first big thing that Jupiter did in the earliest days of the solar system was very nearly destroy the Earth. As the first planets began to form, Jupiter was already gaining an incredible amount of mass, circling around the giant disk of gas and dust that surrounded an infant star. As Jupiter became bigger and heavier, it started getting pulled in towards the sun, spiraling towards the center of the disk and leaving a trail of nothingness in its wake. The powerful gravity of the massive planet grabbing asteroids and slingshotting them in all directions, exiled to interstellar space, launched straight into the heart of the sun, flung towards a developing Earth. You can imagine Jupiter like a humongous space Roomba that's just circling through the mess of rock and dust and gas that was the early solar system and totally disrupting everything in its wake. This essentially halts the formation of any new planets, and Jupiter even comes so close to Mars that the red planet's growth is permanently stunted, never reaching its full potential. If Jupiter had come any closer than it did, then the formation of the Earth would have been disrupted as well, but it was another giant that would come to our rescue. You see, the formation of Saturn would change the path of Jupiter. As Jupiter moves inwards, Saturn follows, and a battle begins. As these two colossal titans draw closer, their immense forces of gravity start to push and pull on each other, and the energy from this gravitational wrestling match starts to accelerate the two gas giants. They are moving faster and faster around the sun, and as they do, they start to slowly spiral away, returning to the outer regions of the solar system, leaving behind just enough material to form you and me and the inner planets as we know them today. Now, you probably learned in school that the planet Jupiter is a big, dense ball of gas with a relatively small rocky core in the middle. That's what most scientists believed for quite a long time, but what we learned back then wasn't entirely true. You see, the outer shell of Jupiter is made up of thick clouds that are filled with ammonia and water floating in an atmosphere of hydrogen and helium gas. Water vapor was first detected on Jupiter in 1995 by the Galileo spacecraft. It only makes up around 0.25% of the planet's atmosphere, but that still adds up to millions of times more volume of water than what we have on Earth. Water is primarily located in the outer solar system. It actually doesn't originate in our neighborhood. The only way that water was able to migrate inward and begin flooding the Earth was thanks to Jupiter's gravity. It would grab big chunks of ice and slingshot them in our direction. In the clouds of Jupiter, the temperature is below -100 degrees Celsius. Water ice crystals interact with ammonia, which acts as a natural antifreeze, allowing liquid water to exist in the upper cloud layer. As droplets collide with ice crystals, the clouds become electrified and trigger the gigantic lightning storms that rage all across the surface of Jupiter. This super chilled water and ammonia mixture eventually clings together into slushy hailstones that fall down into the lower atmosphere, where they melt into rain, evaporate, and then rise back up to start the process all over again. These jets of hot gas that rise up to fuel the raging storms on the surface reach deep down into the planet's atmosphere. This is what we are seeing in the Great Red Spot. Not only is it thousands of kilometers in diameter, it also extends down hundreds of kilometers into the ammonia rain. The red spot reaches up higher than any other clouds on Jupiter, extending above the surface level and absorbing more UV light from the sun, which then reacts with chemical compounds in the storm and creates that deep red color. Imagine a storm cloud 10 times taller than Mount Everest and 10 times deeper than the ocean, and that still wouldn't even be big enough to capture the scale of the red spot. As we descend down below the clouds and into the lower atmosphere of Jupiter, the temperature begins to rise. Heat is caused by atmospheric pressure, which is caused by the intense gravity of the giant planet. The further down we go into Jupiter's gravity well, the more the heat and pressure builds up. It's like traveling through a fog that becomes thicker and thicker until eventually it becomes a liquid. The environment is so extreme that only hydrogen and helium remains. Below the final layer of gas lies an ocean of liquid hydrogen, the largest ocean in the solar system, hidden beneath the clouds of Jupiter. So while the giant planet is definitely covered by a thin shell of gas, it's definitely not made of gas. It's a liquid planet, but this is a far stranger liquid than anything we've seen before. Here on Earth, we can liquefy hydrogen by making it very cold. The atmospheric pressure on Earth lowers the boiling point of hydrogen to around -250 degrees Celsius. On Jupiter, the opposite effect is going on. The intense pressure raises the boiling point so high that it can exist as a liquid even at temperatures well over 1,000 degrees. But we're still only talking about the outer layer of Jupiter. The liquid hydrogen ocean is about 20,000 kilometers deep, about 2,000 times deeper than the Earth's ocean. And as we reach the bottom, the pressure and temperature created by the gravity well causes something really weird to happen. Under millions of times the pressure of Earth's surface, at 10,000 degrees Celsius, hydrogen changes state into something called metallic hydrogen. Now that doesn't necessarily mean it becomes metal. It's not solid, it is still very much a liquid. The reason that they classify this supercompressed hydrogen as a metal is because it takes on the same conductive properties of metal. Jupiter's gravity squeezes so tightly that electrons break free from the hydrogen atoms and flow freely throughout the liquid, generating an electric current. This liquid metallic hydrogen makes up the majority of Jupiter's interior. It's about 40,000 kilometers deep, and down there at the bottom of everything lies the solid core of Jupiter. Kind of. So we previously believed that there was a compact, dense object in the middle of Jupiter about the size of the Earth and made up mostly of iron and rock, which made sense, but new research is uncovering that Jupiter's core is much more fuzzy, as in the transition between liquid metal and solid core is not a hard line, meaning the two layers kind of mix together. We're not sure if that's a weird characteristic that's unique to Jupiter, or if all gas giants are like that. We haven't studied Saturn anywhere near as much, so we're not sure if it's got the same situation going on inside. This could be totally normal. Now, it's thought that if Jupiter's core is weird, then it's likely due to some massive collision that occurred in the early days of the solar system. There might have been a rocky planet 10 times the size of Earth that was floating around out there until it slammed into Jupiter. The energy from that would have scattered and diluted Jupiter's solid core. It might also help to explain how Jupiter managed to grow so big. If all of this compressing and superheating of hydrogen and helium sounds familiar, that's probably because you've heard about how stars are formed. It's much the same way that giant planets come to be. Gravity pulls and densifies and heats until the hydrogen is pushed so far that the atoms fuse together and generate so much nuclear energy that the entire body ignites into a white-hot ball of plasma. The reason that doesn't happen to a really big planet like Jupiter is that it's just not heavy enough. The planet would need to be about 75 times heavier to trigger a fusion reaction. Now that also doesn't mean that there isn't an incredible amount of energy generated in the core of Jupiter. We have that vast quantity of liquid metal hydrogen with its free-flowing electrons, and when that electricity is combined with the planet's rotation, it becomes an incredibly powerful electromagnet, 20 times stronger than the magnetosphere of Earth and about 20,000 times larger, and it extends so far out into space that the 4 largest moons of Jupiter orbit within its magnetic field, and it also adds to another unusual occurrence on Jupiter, the Great Blue Spot. Weirdly enough, it's not actually blue. The spot is a magnetic anomaly that speaks to just how strange and unknown the magnetic field of Jupiter really is. On Earth, magnetic field lines originate from a very specific point at the North Pole and loop around to re-enter at the South Pole. On Jupiter, the magnetic field originates from a wide area in the northern hemisphere that's just a little offset from where you'd expect the pole to be. The magnetic origin point is highlighted by a gigantic aurora that is almost always present above the surface of Jupiter. The northern aurora is also very hot, and that's likely what triggers this insane cluster of cyclones at Jupiter's North Pole, a ring of perpetual hurricanes that circle around one monster storm. The outer ring of 8 storms are each around 2,400 kilometers in diameter, while the central hurricane is over 3,000 kilometers wide. These infrared images taken by the Juno spacecraft show something from the pages of cosmic horror, like a portal straight to hell. Something similar but also totally different happens at the North Pole of Saturn, except that planet's storm takes on the shape of an almost perfect hexagon. We don't know why that is, but it just helps to illustrate that weird stuff happens around the powerful electromagnets generated by these humongous planets. The magnetic field lines that originate from the northern region loop around to re-enter at the South Pole, which is pretty normal except for when it isn't. Periodically, the magnetic field will re-enter Jupiter through the Great Blue Spot, essentially creating a second South Pole. The Great Blue Spot just so happens to exist at the same latitude as the Great Red Spot, right around the planet's equator region, which is just one of many contributing factors that makes us think that there's something weird going on with Jupiter's equator. For one, the shape of Jupiter isn't a circle, it's more oval-shaped with a stretched-out middle region, and this is also reflected in the strange asymmetrical shape of Jupiter's magnetic field lines. Those same lines that extend out from the Earth follow the shape of our planet very closely, but the lines around Jupiter follow some totally other shape that's kind of stretched out and lumpy, kind of reminds me of lemons. Now, there are a few theories out there about why that is, or what other force in the solar system might be able to influence the power magnetism of Jupiter's liquid metal core, but we're gonna have to save that for another video.